from Earth. It's Space Radio. This is Pulsar, and coming up, we're talking about a bad case of stellar heartburn, and Hayabusa 2 gives a kiss to the asteroid Ryugu, and of course, taking listener questions about all things in this beautiful universe, because that's exactly what this show is about. We record every Thursday at 4 p.m. Eastern. So call 888-581. No, don't call. Do not. We got rid of the phone number, but I'm just running on autopilot now. There is no phone number. There's just a voicemail on the website, spaceradioshow.com. You can leave a voicemail from anywhere in the world at any time. And in today's Blue Shift, I'll be talking about the responsibility of scientists to the community. But first, the news. Hello, space fans. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Ohio State. And for the next half hour, your agent of the stars. Got an exciting show for you today on Space Radio, where we talk about all the amazing, beautiful, powerful, and sometimes devastatingly ugly things in this universe. This show lives on listener questions. We record every Thursday at 4 p.m. Eastern here in Studio A of WCBE Radio Columbus. So leave a voicemail on our website, spaceradioshow.com, and I will play back that voicemail, and then I will answer the question. Very straightforward. You can also follow along on the live streams on YouTube and Twitch. Again, spaceradioshow.com for those links, and you can tune in live every Thursday at 4 p.m. from around the world. We have space cadets coming in from Ashburton, New Zealand, Atlanta, Georgia, Eureka, California, Richmond, Virginia, Germantown, Maryland, Kempner, Texas, Lancaster, California, Carlo, Ireland, Lehigh Valley, Pennsylvania, and of course more. Seriously, folks, I've only prepped 10 minutes of show material tops. Actually, not even that. So get those questions in. Live streamers, I forgot to pick a Blue Shift topic. So what did I say it was? The responsibility of scientists. Okay. Remind me of what my Blue Shift topic is, because I forgot to pick one. Or it should just be cheese in space. Sorry, just had a cheese moment. I had a cheese out there. Before I start taking questions, I want to share some interesting bits of news I caught recently when it comes to space. And there's one cool astrophysics story and then one cool solar system-y story. So the astrophysics story is there's this nova, which is a flaring star in the constellation Andromeda that has basically been flaring roughly every year for the past 1,000,000 years. This is ridiculous. And to make nova happen, this is such a fun scenario. You have the leftover remnant of a star called a white dwarf. It's, small. And then surrounding it is another star, a binary companion. And that binary companion is close enough to be to the white dwarf that some of that material gets pulled onto the surface of the white dwarf. And it just builds and builds and builds, like your anxieties and your tensions. And it builds a thick atmosphere of hydrogen until it just reaches a boiling point and goes nuts. Critical mass nuclear fusion chain reaction blows the whole thing off in a huge flash, and this increases the brightness of this white dwarf to be like 1,000,000 times that of the sun, so we can see it pretty easily when these nova go off. Now, this is a very common scenario. Nova happen all the time. It's not so happen to have these kind of recurring nova where the situation is just right, where that binary companion dumps material on, it flashes, and then it dumps material on, and it flashes, dumps material on, and it flashes, especially every year. Like, boom, boom, boom. Imagine how quickly this much material must fall onto the surface of this white dwarf in order to trigger this nuclear chain reaction. And it's able to do it every year, and it's able to do it reliably every year for 1,000,000 years. As a consequence, every time there's one of these flashes, it sends this huge blast of material out into the surrounding medium. So this particular system, this star, has this giant shell, this like 400 light years across, of material left over from all these flashes, all these nova. So that's way out there in the Andromeda galaxy, thankfully not close to us. Close to us, however, is the Japanese Hayabusa 2 spacecraft, which is honing in on the asteroid Ryugu, getting there tonight, and you can actually follow along live to watch this happen. They're doing a sample return mission. So the the spacecraft Hayabusa is going to send down a little arm thingy, kind of looks like a proboscis. And then out of that, it's going to spit out a little canister of stuff that's going to blow up. So it's going to hit the surface and go poof, and send a bunch of stuff out. And then it will suck it up with this tubey proboscis thing. I'm sure they have better and much more technical names for all of this, but that's how I'm imagining it. So it's going to take a little slurp of a comet, put that little slurp in a canister, and send that canister back to Earth. After a couple years, it will land here on the surface of the Earth, and we can open it up, and we can taste a comet. I'm sure there's some actual research and science applications other than seeing what a comet tastes like. Or sorry, asteroid. It's an asteroid Ryugu. We're going to find out what an asteroid tastes like. You know, some scientist somewhere, when no one's looking, is like playing with the sample. You know that, they wet their finger and, touch it a little bit and then taste it again. You know they're going to do it. Let's not joke around. Someone in this world has tasted an asteroid or a comet bit that's been returned from space. I'm just saying, it's got to happen. It's got to happen. That's the latest and greatest when it comes to space. Let's have some questions. Hey, space cadets, what's my blue shift topic again? Responsibility to science. Wow, that's fake. That's fake. I'll cook up something for you. Hey there, Psycho Cat 749. How's it going? All right, I see you guys are already popping up the questions, but I do have a voicemail, so I'm going to do a voicemail. And then the second half, I'll do a bunch of your questions. Does that sound like a plan? It better, because that's the plan. We've got a voicemail ready to go. Greg, hit the button.
Hi, my name is Azra. Why is the Earth tilted?
What a wonderful question, Azra. So the Earth is tilted. We're at like 23.5 degrees, and this is relative to our orbit. So we orbit around the sun, and we're also spinning like a top, but we're not spinning like a top straight up. We're tilted off to the side by 23 degrees, and this gives us all of our wonderful seasons that we all get to enjoy, especially winter, when it grinds into your very soul. Sorry, I have some issues with winter. I won't go there. Now, when you look at the different tilts of the planets have all sorts of tilts. Some have no tilt at all. Most extreme ones, like Uranus, are like totally tilted on their side, where their North Pole points directly into the plane of its orbit. So it's like 90 degrees. It's crazy. And there's all sorts of cool physics that go into the tilts. It's all sorts of processes. So it could just be random little tugs and pulls from all the other planets in the solar system. Yeah, we're close to Venus, we're close to Mars, Jupiter's way out there, but it's pretty big. And sometimes these little gravitational nudges are just like little whispers that can actually start to tilt planets on their side. This, of course, takes millions of years to do, but it's totally possible. Sometimes there are giant impacts. The Earth, when it was first forming, was smacked by something the size of Mars very early on. That's what gave us our moon. It may have caused our tilt. Certainly when you're looking at something like Uranus, with its massive tilt, something dreadful must have happened to Uranus long ago to make that kind of disaster. And then you look at something like Mars that doesn't have much of a tilt at all, and you're like, well, okay, it's, pretty mild history. So every planet is going to have some sort of tilt. We happen to end up with 23.5 degrees. It could have been 15. It could have been 57. We just happen to end up with 23. There's no particular reason why the spin of our planet has to be perfectly aligned with the plane of our orbit. Now, there is a relationship between our moon and the tilt of the Earth. If we didn't have the moon, our tilt would change. See, these tilts aren't fixed with time. They actually vary. The planets will wibble wobble. They won't fall over, but they will wibble wobble. And I'm talking very slowly, like hundreds of thousands, millions of years, these tilts will change. But our tilt is stabilized by the moon. The moon, having this big moon in orbit around us, it almost acts like a counterweight that prevents us from changing our tilt very much. So if we're ever tempted to like lean in or lean out, just the sheer weight of the moon in orbit around us is like, no, hold on. Are you sure you want to do that, Earth? And Earth's like, okay, good, thank you, moon, for calming me down. So we probably have the moon to thank for our stable tilt. Could you imagine? You're about to, because I'm asking you to, how the evolution of life would be affected if our tilt changed all the time, right? We have these regular, dependable seasons, and so much of life depends on that rhythm of the seasons. It can count on it. But what if over the course of, say, 10,000 or 100,000 years, we went from 23-degree tilt to 90-degree tilt? That would be a radically different looking Earth. And then what if it flipped upside down and went back and forth? And over the course of tens of thousands or hundreds of thousands of years, our cycles of the seasons changed faster than evolution could keep up. That would radically alter the trajectory of life on the Earth. I don't think it would snuff life out, but I bet it would look very, very different. So we might have the moon to thank for us. The one good thing our moon did was, allow for stable seasons over millions of years and allow life to develop. Okay. If you're going to do one thing, moon, it might as well be that. Thank you, moon. That is a fantastic question. Thank you so much, Azra. A wonderful question. I love the simple, straightforward questions, because simple does not mean easy. Simple questions are some of the most powerful questions you can possibly ask about the universe around us. I'm Paul Sutter, and this is Space Radio. This show is brought to you by you. Go to patreon.com/PMSutter to learn how you can keep this show going. And yes, it really is you. It's all up to you. I'm not looking at anyone else. I'm looking at you, and I'm asking you. No, not you, but next to you. There, you. I'm asking you to contribute, and I will see you after the break. Great question, Azra. A meaty wine? It's never aliens. Aliens are never the answer. Okay. It's as closely as the planets do in our solar system. Yeah. Great question, Space TV. Great question. Yeah, Larry, weird and proud. Yeah, go on over. I'll join all the other weird and proud people over on YouTube. We could use some more questions before I start this next segment, or I could do another voicemail. I don't care. Thank you for the $5. Someone's talking about wine. Jack Martinelli, you're the best. Okay, so I'll do a couple questions from chat. It's not too active today. It's okay. It's a quiet time. And I will do another voicemail from Hunter Rothman. Welcome back, everyone. I'm Paul Sutter, and this is Space Radio. We've got more questions ready to go, but remember, you can join the conversation by leaving a voicemail at spaceradioshow.com. Remember, you can do that from anywhere around the world at any time of day. It doesn't matter. It'll just go in a special little thing, and then we can just play the thing. It's magic. It's techno magic is what we're going on here with Space Radio. And that is spaceradioshow.com for the links to the live stream, all that of how you get connected and be a part of the show. We've got some live stream Space Cadet questions ready to go, plus another voicemail. But I'll start off with this question over on YouTube. Are there any plans for colonies on the moon or only rovers? Yeah, so it depends on what you mean by plans. There have technically been plans to put bases on the moon since forever. Like, as soon as we're done with the Apollo mission, like, okay, let's start hauling it up. Let's get the walls and the roofs and the plumbing and the electrical and the HVAC. Like, let's just do it. Get some drywall up there. technically plans have been around for a very long time, but feasible plans that can actually be achieved with modern day technology or reasonable extensions of modern day technology, those are always a little bit sketchy because the moon doesn't have much. All right, the moon has moon dirt, which is great for building moon walls and moon roofs and moon floors, but you don't really get much after that. So you need a lot of raw materials from Earth. And you just need to launch like 1,000 launches to get you your first start of a moon colony. Like you just need tons of stuff. Like it took us forever to build the International Space Station. I don't know how long. It was like 5 years, 6, 7 years, over dozens of launches to haul up the International Space Station bit by bit. So to build a moon base is going to be that much harder, that much rough. Like it's just going to be hard. So there are plans for moon bases floating around, like there always are. But to actually do it, well, plans are great until you actually start doing something and then all your plans fall apart. So we'll see what an actual moon base would look like. Another question over on YouTube from Space TD: can stars orbit each other as closely as the planets do in our solar system? The answer is, oh, heck yeah. Man, stars orbit any way they feel like. There's no rule book. They'll just do what they want. Man, we've got stars orbiting stars closer than Mercury is to our sun and farther than Pluto is from our sun. Like some stars orbit each other like a light year apart. And sometimes there's triple systems and quadruple systems. Sometimes you'll have like a little binary nearby each other, and that's called a tight binary because that sounds pretty cool. You got a tight binary, and then there's a third star orbiting that. Sometimes they're more spread out. Sometimes there's little stars orbiting big stars. Sometimes it's two stars of equal size orbiting each other. Sometimes they're spiraling in to crash into each other. So it's just a mess out there, folks. Man, you look up in that sky, you don't know what you're gonna get. Now, let's switch over to a voicemail. We got a voicemail from Hunter here. Greg, play the tape.
Hello, this is Hunter Rothman. I'm curious about why a string is better than a point particle. What makes it so much better than it being a point particle? Essentially. Thank you. Bye.
A great question here asking about string theory, which is a very hypothetical, super hypothetical, a way to explain fundamental physics. So the modern view we have of fundamental physics and particles is that if you look at an electron, just a good old fashioned electron, the electron really doesn't take up any space. It is a zero-dimensional point. It is a thing that has properties like charge and spin and mass, but it doesn't have any of its own volume. It makes its presence known through its mass and its charge. Like you try to get close to it, its electric charge will repel you, but its mass will attract you. But in and of itself, it takes up no volume. So if you put two electrons together, the two electrons together are, of course, going to take up space because they hate each other. And so they're going to try to be as far apart away from each other as possible. So right there with a system of electrons, you can get some volume, but the electron itself doesn't take up any volume. Some people are bugged by this, other people are not. So don't, I will let you fall on that spectrum of thinking that's all right and not all right on your own. But extensions, highly theoretical, highly hypothetical extensions to our standard picture of how fundamental physics works, replaces all these point particles with strings, with little bits of space-time itself. They're all curled up and wrapped around each other. And these strings can vibrate, they can split apart, they can curl in on themselves. And depending on how they vibrate or split apart or curl in on themselves, they express themselves differently. So if you vibrate one way, then you'll have a certain mass and electric charge. And if you vibrate another way, you'll have a different mass and a different electric charge. And this is like the fundamental hope of string theory, is that you can explain all the physics Like, why do electrons have this certain amount of electric charge? Why do they have this amount of mass instead of another kind of mass? The hope of string theory is that it all comes from the behavior of strings. But string theory is not proven. It has not been tested at all. The math hasn't even been really worked out where you can actually say, oh, yes, the electron mass must be this because this is a string vibrating with this way. This is a hope of string theory, but no one's been able to crack the math yet. So take of it what you will. There's an advantage there that you get to replace these point particles with no volume with little wavy bits of strings. And if that helps you sleep better at night, then go ahead and think it. Now, there's another question over on YouTube now that we're in this kind of particle physics mode from George asking, what are virtual particles and how do we know they exist? So you may have heard this term called virtual particles. I'm going to challenge everyone here that if you ever hear the term virtual particles, they are neither virtual nor particles. When we look at, say, two electrons interacting with the electromagnetic force, in the picture of fundamental particle physics, they are quote unquote bouncing little virtual particles, virtual photons back and forth to each other. And that's how they communicate, quote unquote, they communicate with each other. Just ignore that. It's a very, very poorly chosen bit of jargon that I myself am not very big fan of because it's more confusing than elucidating. So instead, I just think of electrons interacting with electrons. Like, the math is there. Let the math speak for itself. You don't need to put fancy words on top of it, especially confusing sounding fancy words like virtual and particle. It's the way particles interact with each other, but it's a very, very confusing way to picture. So just don't even bother. Just don't even bother. Speaking of interacting, one last question. I've got 30 seconds in this segment. Man, does dark matter, this is Dodgy Blaster, does dark matter interact with dark matter? We don't know. We don't know. It might or it might not. We're kind of still working on it, so give us a little bit more time. We're almost out of time today, speaking of time, on Space Radio. But before we go, it's time for the Blue Shift. What was my Blue Shift topic, folks? The responsibility of scientists community. Yes! Thank you. Oh, PsychoCat, can we ignore M theory yet? Pretty much, yeah. Pretty much, yeah. Should have gotten to it on the show, but string theory, M theory, all of this. Ooh, tough spots these days. Tough spots. Along with like most theoretical high energy physics. It's a bloodbath out there. It's like World War I. But that'll be another show. I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift, my opportunity to get just a little bit closer to you. And recently, I was at the University of Illinois at Urbana-Champaign, UIUC, where that's my alma mater. I got my Ph.D. there in physics in 2011, and I got to come back and give a little talk. I gave the astronomy colloquium there. And I gave one of my favorite talks to do, which isn't about research, but it's about science communication. And it's my favorite talk to do because I do very little talking in it. I have 7 slides, and they're all questions. They're all discussion prompts, challenging scientists to think about science communication, to think about what they are not doing or not doing when it comes to science communication, why they should do science communication, what are some ways they could, what are some barriers, what are some problems with the existing model. It's a really, really fun talk to give because no two talks are the same, no two departments are ever the same. And in this discussion I had with the astronomy department at UIUC, we really, really dug into why scientists should communicate with the public. And I'm glad I have a favorite answer, and I'm glad someone else gave my favorite answer, which is you, the public, literally paid for it. It is your tax dollars that paid for this science. I mean, you didn't pay for the Hayabusa probe. That was the Japanese tax dollars. But this research that I presented earlier about this nova that recurs every year, you paid for it. It's your money. And usually when you spend money, you like to know what you got. And in this case, you got some really cool stuff to know about the universe. And it shouldn't be locked up in ivory towers. You're just renting the brains of scientists to figure out stuff for you. It is, you can demand the right to know what we've learned in science because you literally paid for it. It's yours. And if scientists aren't doing a good job of communicating it, that's the scientist's fault because it's your money. You deserve it. You paid $10. You deserve to know what you got. And so I challenge scientists around the country to find ways to communicate their science. They don't have to do it well. They just have to start doing it because the people they're talking to, the non-scientists, paid for that knowledge. Whew. Got fired up. Heather's looking at me. We're almost done. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of space radio. Once again, I'm Paul Sutter, and this show is brought to you by the Ohio State University Department of Astronomy. Learn more at astronomy.osu.edu. This show is also brought to you by you know who. Visit patreon.com/pmsutter to learn how you can contribute. Thanks to Heather for producing today, Nancy Graziano for wrangling the Space Cadets, Dan Michalko for being awesome, and all the fine crew at WCBE Radio for making this show possible. We record every Thursday at 4 p.m. Eastern. You can leave a voicemail on the website, or you can catch the live streams on YouTube and Twitch. Go to spaceradioshow.com for the links. And of course, thanks again, Earthlings, for listening. See you next week. And remember, science is for sharing. End of transmission. We're done. Cut. Out. First down. I don't know my referee hand signals.
Everything sounded good on YouTube.
Oh, you were following along on YouTube? Okay, perfect.
But yeah, I was listening for the first 15 minutes. Voice on the side.
Okay, so we can pull from YouTube if we're having some audio issues, folks. I'm still running the live stream. No, it's cool. Greg usually comes in and chat. No. The Space Cadets love Greg more than me. We had a contest and Greg won on Valentine's Day. Yeah. Was that heartbreaking? I was kind of expecting it. Because, I mean, Greg's got that charming smile in receding hairline. And that's just hard to beat. It's just hard to beat. In sweater that he wears every week.
Just for you.
It is. He's like, it's Thursday. I'm putting on Paul's favorite sweater.
Gets all snazzy,
Yeah.
cologne and
Oh yeah, the spritz. He does like 10 spritzes of cologne.
he does.
Like it's like Axe body spray on a teenager. It's a little bit much. It's a little bit much.
He cleans up his chucks for you.
He does clean up his chucks with just like a paper towel.
With a paper towel and a little bit of the Tide.
Oh, I didn't know you could do that.
Yeah.
Oh, now I know how to clean my chucks.
There you go.
Wow, learning new things.
Mhm.
Can you be my producer every day?
Yes.
Can you be my forever producer?
I will. I feel so loved now.
Oh, do you want a dinosaur sticker?
I do.
So I got Valentine's dinosaur stickers. You want to say hi to the live streamers? Hey, Space Cadets, this is Heather.
Hi.
Heather's producing today.
Yay.
Um,
I kind of know what I'm doing.
She does a better job than Greg. Do you want a dinosaur sticker?
I do.
What do you
Let's
want?
see. I want the pterodactyl.
Oh, great. It's technically not a dinosaur. It is a flying lizard.
Flying lizard.
They're related to, but not dinosaurs.
Thank you, but then why is it on the sticker sheet?
You know what? I didn't make the sticker sheet, okay?
All right.
I just didn't. I was not in charge of this one.
You are such a diva. You need to calm it down.
Total diva. It's in my writer that dinosaur sticker sheets must only contain dinosaurs.
Darn it.
Darn it. I'm giving myself a little smiley face, son.
Because you're a bright ray of sunshine. Every time you come in here.
Every time.
Mhm.
Everyone smiles. Or grimaces. I can't tell.
Yeah, I'm not sure.
Uh,
It depends.
It depends. Yeah.
Depends on how abrasive you are that day.
What's Paul's mood today? Thank you, Heather. See you later, Space Cadets. Everyone's saying hi to you, by the way.
Oh, hello.
Yeah. See? Hi, Heather. Hi, Heather.
Hi.
See?
Mwah.
Aw.
You guys are the best.
Hey. There you go. This is the start of something beautiful. I'll see you guys next week.